The objective of this test is to determine how quickly the AK-47M and the SKS barrels cool down after heating up from a certain number of rounds. The comparison will use the negative slope angles between the highest recorded temperature and the designated natural temperature reading. To reduce random error, the average slopes from the 3 iterations of each test condition will be calculated, giving a clearer and more consistent picture of how each rifle cools over time.
Both the AK-47M and the SKS were developed by the Soviet Union and uses the same ammo, that being the 7.62 by 39 cartridge. Generally speaking, the AK-47M is more compact and lighter when compared to the SKS. However, the SKS has a longer barrel than the AK-47M and therefore has greater accuracy and range. Despite the SKS having a longer barrel, it uses a short-stroke gas system, while the AK-47M uses a long-stroke gas piston.
So this is the data acquisition setup. We have the non-contact thermal sensor pointed directly at the end of the barrel of the AK-47M. The sensor has a sensing range of 0 to 400 degrees Fahrenheit, and it outputs 0 to 5 volts. The wires from the sensor are connected over here to the DAC, and the power for the sensor is coming from our 12-volt battery on the Kubota tractor. That signal is fed back to our computer so that the temperature data can be acquired from the sensor.
The procedure will include testing 2 different guns, both in rapid fire and regular fire. That is defined as rapid being 1 shot every half a second, and regular fire is 1 shot every 3 seconds. While that's happening, the DAC is recording the temperature of the barrel, and it will show the barrel getting hotter with every shot, while also slowly cooling down once the testing is done. Lastly, to be consistent, the same ammo will be used from the same brand the entire time.
This setup is a old wooden spindle, old cinder blocks, sandbag for stability, and 2 stability blocks set up for infrared thermometer. This private property is set up for range safety, shooting into a secure sand pit with nothing downrange. The DAC setup and the lab view are ready to go. The range is clear. It's time to start.
Here's a plot of a typical test. The graph indicates a starting temperature of about 50 degrees. Peak temperature is recorded around the time that the last round is fired, and from there, the temperature slowly drops off until it returns to its starting temp of around 50 degrees. With this test in particular, the SKS barrel took almost 15 minutes to return to its ambient temperature. The results show that the AK-47 barrel temperature peaked around 90 degrees and increased by about 2.18 degrees when going from a normal rate to a rapid rate. The SKS barrel temperature peaked around 70 degrees and similarly increased by about 1.8 degrees when going from a normal rate to a rapid rate. Due to the small increase in peak temperatures, the cooldown time was only increased by about 45 seconds for each rifle. Here is a graph to help visualize the differences in peak temperature between the AK-47 and the SKS. The SKS barrel temperature peaks around 70 and 72 degrees, while the AK-47 peaks around 90 and 92. This is roughly a 20-degree swing clearly showing that the AK-47 barrel gets hotter than the SKS barrel when firing the same number of rounds. The cooldown rates were calculated based on the temperature difference between peak temperature and final temperature versus the cooldown time. The AK-47 barrel had a cooldown rate of about 3 degrees per minute. The SKS barrel had a cooldown rate of about 1.4 degrees per minute. For both the AK-47 and the SKS, the cooldown rates were consistent for both tests. This makes sense as the rate that the barrel cools down should stay consistent unless outside disturbances are impacting it. In conclusion, when using the same type and quantity of ammunition, the AK-47 barrel dissipates heat at a faster rate than the SKS barrel. The results show that firing rounds at a rapid rate only increases barrel temperature slightly, and therefore only affects the cooldown time slightly. The AK-47 barrel dissipates heat at a rate of about 3 degrees per minute, compared to the SKS barrel's cooldown rate of about 1.4 degrees per minute, meaning the AK-47 is more efficient in barrel cooling and will be ready to fire again in less time.